I'm Ayman Hamrouni. I'm a PhD student at KU Leuven.
I'm Alexandra Lopes. I'm in Nokia Bell Labs in Finland.
I'm Fabian Portner. I'm a doctoral candidate at the TU Delft.
Work Package 2 is actually at the heart of the project.
In Work Package 2, we would like to take these solutions to our actual networks, because the networks are already operating, so we need to be able to adapt to the principles of operation of cellular networks or wireless networks in general.
The Work Package leader is Trajan Abrudan from Nokia Bell Labs in Finland.
In order for joint communication and sensing to happen in reality, we need to align with the existing wireless standards. Without aligning with the current wireless standards, this will never get into practice. This kind of research requires a lot of technical background, statistics, mathematics, and machine learning.
Why would you need the sensing in joint communication and sensing?
If a hospital wants to deliver blood, we can use, for example, drones.
But then the sky will not be empty, right? You would have other drones, cranes, and you need to somehow coordinate and manage between these drones.
Oh, that's true. And that's why we need sensing implemented in our networks. It's going to be very useful for these type of use cases.
The work package that we are working on tries to tackle exactly these issues, mainly the hurdles that are in the way of getting sensing into the communication systems.
One of the important things of this network integration is like thinking about the standardization.
Standardization is important because if you don't do it, you're going to have chaos. So, Ayman, what do you think? What is the core thing on integration that you were looking at?
Well, I would say a resource allocation is really important because you have a spectrum that is limited. We would want to know how to allocate bands or the communication spectrum with a high data rate, low latency, while also enabling a very high sensing accuracy.
Personally, I consider privacy and security the biggest issue. The thing is that these sensing signals cannot just be used by legitimate base stations to track things, but also by anyone, because I mean they just spread around the environment, right? Like you can sit there and track those drones as anyone can. So you could intercept those blood deliveries, you could track someone's keys if you have a tag on them and something. And that's something that you would absolutely want to avoid, because otherwise it's no use talking about integration. We're not going to use a system that compromises people's privacy and security.
We have preliminary results, and the students have been, let's say, cranking out their first publications.
In Work Package 3, we mainly focus on two challenges. And the first one is about the trade-off between the performance and also the resource limited.
The second challenge would be the interference. JCAS operates in very busy environments where all the user equipment, the base stations, and the vehicles can communicate and sense at the same time.
Basically, in this work package, we want to get information out of the signals and do something relevant. Cellular communication is, of course, of very large strategic importance for Europe. We have been leading this field already since the second generation, and now we're already talking about the sixth generation, so it's important for Europe to keep leading the innovation. And as joint communication and sensing is a very important topic for 6G networks, this project specifically is also very important for Europe.